Okay, now following is what I'm going to show as I do a normal presentation. I started off first of all, as I showed you, some lovely pictures of New Zealand, but that's just to point out that while I'm waiting for people, it tends to lighten the mood. I'm sure you've got other tools in your, no doubt, considerable sales bag to be able to get people's interest anyway. But I do find that quite useful, to be honest. Anyway, apart from that, I then go and show the icons. Now, I've got a whole lot of icons here. The first point I want to make is that we have three modules: Instrument Manager, Panel.des, and then everything else except those two comes with Elecdes. So there's a fair swag of tools. Elecdes was the original package that was developed. Instrument Manager. Now, Instrument Manager has the ability to do instrument loops, can do MCC circuits and I/O cards and a few other things as well. It's rather data-centric. It will basically populate graphical templates with information to produce loop diagrams and things like that. Say it also does instrument data sheets. Now, Elecdes itself certainly has instrument capability. As you can see, we have the symbols in there, but it doesn't do instrument data sheets. It doesn't have the ability to map data to PNIDs and things like that. But the point being is it's quite a useful tool to be able to build the graphical templates that Instrument Manager uses. The other module I've got here is Panel.des. As the name implies, it was originally developed to do panel layouts in 3D. And there's an example of a 3D panel. It was designed to work out wire lengths, which of course you need to have a 3D model to work out accurate wire lengths. The trouble with that is that while most manufacturers do have digital catalogs these days, a lot of them don't go into the detail needed to produce a realistic model. For example, how far a device sticks out from a mounting plate, or the length of the wire will vary, especially for a big device, depending on whether the terminals for that device are on the top, the bottom, or the sides. Penalties as default will use the wire length from physical center to physical center. So as I say, GE, which used to be called Alstom in the UK, they actually built their own set of protection and control relays, but they didn't actually know what the dimensions were, and they actually paid us lots of money to develop 2D panel layouts as part of Elecdes. And what you can see there now is an example of a 2D PLC panel. You generate a bill of materials in Elecdes automatically, and you can use that bill of materials to go and place devices on your 2D surfaces for your 2D panel layouts. The other point I want to make here is Panel.des these days, 99.99, in fact, pretty much everyone, with a couple of exceptions, uses Panel.des Raceway, which, as the name implies, you can put in trenches, cable trays, conduits, and this is a model that's integrated into an existing switchyard. We save 12 miles of wastage compared to their existing model of 2D guesstimation of how things work. Those coloured boxes are ours. It'll work out cable length, cable tray fills, cross-sectional areas, all that sort of thing. It'll warn you if your trays are too full and try and find an alternate route. So it's got some powerful tools. But I don't show that. My colleague Andy Bonfield, who you all know, is the one that shows Instrument Manager and Panel.des. All right, the next thing I want to discuss is, I'll go to my PowerPoint. Okay, some of the key things to point out. Now, when I do a presentation, I'll normally go through this PowerPoint first, which has a few slides, as you'll see. I then try and concentrate on the drawing tools, and then finally I chuck out all the rest of the reports. I could, if you were really interested, I could bring this demonstration down into two separate ones, where I do go through this PowerPoint first and generate the reports, and then I show a separate little movie demonstrating the drawing tools. The reason I do show the drawing tools is because I find that often engineers are unaware of some of the things that we can do that can speed up the drawing process. And of course, these days it's all about efficiencies, less people doing more work in less time. So it is worthwhile pointing out engineers some of the drawing tools that I do show, and I will show. But again, one of the key things here, which is straight away is a bit of a hook really, is the fact that we've got a very open two-way database link. We can extract text and attributes from any DWG file, including legacy drawings. We can extract that information out to a database file, and using the tools that we provide or tools that engineers are familiar with, like SQL Server or Access or Excel, they can modify information. So it has things, for example, with the two-way database link, we also access catalogs, and the catalogs can be of two sorts. They could be generic catalogs, green lamps, blue lamps, etc., 20 amp fuses, or real manufacturer's information. So you can do things like what if scenarios. You could start off with a green lamp, and then later on export that information out to a database, and the costing people could use Excel to go and change the green lamps into a particular manufacturer to see how much money it's going to cost, change to another manufacturer to see if it saves them any money. We have also had customers link our software to just-in-time ordering software, such as that is produced by SAP. But there you go. So as I say, the key thing is our two-way database link, be able to modify information on a global basis, project-wide, rather than having to do it a drawing at a time in a simple time, maximizes efficiencies in terms of modification of information. Easiest way is to show you. So let's go and share my other screen. Yeah, if I can drive my mouse. Okay. All right, now eBase is a little project manager. And it basically is defining what drawings you're looking at. Now, I've set up a few little projects here. You can see this project here. I've got 3 drawings. It could be thousands of drawings. We've actually just recently increased the maximum number of drawings in a project. But as I say, and this, I've got 3 drawings: US Demo 2, and US Demo 3. Now, another one of the tools I'm going to have a look at here, cancel that, is our little batch printer. We actually built a batch printer before Autodesk had it. But it's actually quite a useful file viewer to demonstrate this key thing, the open two-way database link. And for this, I'm going to open up a drawing, US Demo, and if I zoom in, you can see that I've got a lamp, which is called DS3 in green. Now, I might want to change it to DS1002 in red. Now, as I say, with normal AutoCAD, I have to open up the drawing, find that, and use Attribute Editor or Text Editor, basically, with a few exceptions. With our software, I don't have to worry about that. I can go to eBase, I can go Global Edit, and here you can see I can find, there's my DS3, same manufacturer and catalog number, catalog select. Now, as I say, the fact of the matter is I've got a generic catalog. I can go and change it to be R for red. Okay to that. And I don't, well, make this big actually. I don't want it to be DS1 to a DS10. I can go and increment to decrement minus the tag name minus 999. Oh no, sorry, increment by 999 is what I want to do. Change it by increment it to DS1000, and you can see it's changed it. Depending on what you're looking at, the sort parameters change. So if I go up to here and I go to terminals, I can say all of my terminals in the same terminal strip. I'm going to make it TB100. So I quickly go through this, point out a few other things, wires, cables, miscellaneous. Anyone else's text or attributes will appear in that little section there. Title block, as the name implies, is pretty understandable. Extra parts, you might not only have to buy a relay for a panel, but you've got to buy a mounting plinth to screw it into the panel with. So things that you want to factor into your cost but don't need to be seen on the drawing. Termination, we added initially when people were doing panel layouts in 3D, but the point I want to make here, if I have a look at wire 8, as I say, there are various wiring methods available around the world. And for example, if I've got 4 devices looped on wire 8, as you can see here, with the old 3D model, it would work out the shortest distance to run that wire 8, depending on the location of those 4 devices inside the panel. But the 2 possibilities: number one, if you don't have a 3D model, it can't work out the shortest distance. And number 2, people might want to wire things in a particular order. And that's what W order stands for, wire order. I can say I want to have it going from there. There you can see there's an attribute wire order to there and to there and to there. So basically, when it produces an automatic from to wire list, you can actually overrule things and define the order you want to wire things up. And a few other things in there as well. Zones, those are continuous line numbers, which are quite often common in America. By the way, I also tend to point out to people that you can add extra attributes if you want to. We do have a minimum set of attributes for things, but you can certainly add extra attributes for your particular devices. Now, if I hadn't spent so much time doing that, of course, I would have done it in about 2 seconds. But just to prove it, I'll go and have a look in here. There's my batch printer again. And if I have a look back at the US demo, I can see that before what was DS3 in green is now DS1000 in red, and I haven't touched it in the CAD session. So it's one of the cornerstones of our software, being able to modify information globally without being in the CAD session maximizes efficiencies. Okay, on to the next slide. Comprehensive customizable libraries. Go through a few of these. Well, if it's comprehensive, why would you customize it? There's a couple of reasons for that. But one of the key things about our software I hear all the time is we are far more flexible in terms of everything from drawing styles to cross-referencing styles to colors and line types than a lot of the available DWG style packages that are out there for electrical design. We certainly don't lock in. This is to assuage the CAD drafters. We certainly don't lock them out of any CAD commands, but we reduce the need to use them. Such things as, for example, visibility of attributes and things like that. Automatic line breaks. It still amazes me these days, even some of the biggest consultants in America do not have automatic line breaks and automatic symbol insertion. So to do a drawing, they have to insert the symbol first and then do the lines for the conductors afterwards. So let me show you an example of that. And for that, I'm going to go back to my other screen. Okay. And again, let me get into the CAD session. Now, the first thing I'm going to do here is I go and open up a border, and I'll go and pick an A2 or a C size border in American speak. There we go. And again, just draw a line. Now, L for line. What I explain here is that we keep it simple, which is why we can generate wiring diagrams automatically. And for complicated relays that some of the other packages have problems with. But I've drawn a line from there, and then I can go into a symbol and go and pick, for example, a normally open push button. Now, again, if I go and put that in there, I reinforce it's coming up with PB1, catalog select, and I'll go and pick a 100M push button, which I've given the catalog number as 100 APB. Go OK to that. Now, the first thing I'll see is that it comes up with this warning message. And it's actually a very useful thing because not only can we speed up the design process, but another one of the useful features of using our software is we can reduce errors. It's having a look at that model, that project that I had the 3 drawings in, and it's saying, hang on a moment, you've already got a PB1. It's on that drawing there. It's called on US demo. So, oops, I better not call it that. I return to the attribute dialog box, and then I've got a plus greater than sign there. Hit the next available one, and you can see it jumps straight up to PB10. So that's quite useful to point out, reducing duplication errors. Go OK to that. Now, as I say, there I've got my PB10. It amazes me still the number of people that have to insert the symbols first. If they want to move it to a vertical line, they would have been left with a gap where I was before. Not so with our software. So that's the point I want to make there. Now, again, if I go back to my CAD session, out of the box, we have those 4 examples. Metric, that's the IEC symbols, IEC 617, Imperial. Somewhat ironic, America got rid of the British Empire in 1776. Australia is a slight variation of IEC, although they seem to be reversing back to normal IEC now. And Canada is the American IEEE symbols, but in the metric environment. So there's that. I also point out here is that comes back to flexibility. We have a multi-client library manager. We did this for a customer in America. They were doing work for various power companies, and the various power companies wanted to have different sorts of things in terms of styles of cross-referencing, catalogs that they used, colors, line types, layers, all that sort of things. So you can set up those parameters once, like Allen Bradley or Semco, and then consultants, which make up our biggest market segment, they can actually set up a whole set of parameters for different clients. And if they're doing work for the client, click on the client name and we'll load up their parameters automatically. Of course, it does require setting up once, but it's not a long process. And once you've done it, you've got it there for good. So that's quite another useful thing. I cancel that. The other things I do tend to show MCC builder, but I'll come back to that. Okay, cancel. The other thing is, in terms of flexibility, we had, for example, GE in UK was doing work in Canada. They basically replaced all of the IEC symbols with IEEE symbols by clicking on that button there. If you've got customers that want to get more intelligent onto drawings, they might have some block symbols of their own. and they might not have the standard attributes that we need. So again, you can use this as a useful tool to go and change their block for a push button into our block for a push button, and then they'll get things like bill of materials and from to wire and cable list and all that sort of thing as well. So that is important. Let's go back to the other screen. Oh no, actually, I'll show you here again. If I go close some of these down. Okay, now at this stage here, I'll open up another thing. This is an example. We have all the standard three-phase and single-phase symbols, but again, these days, and this comes back to the customization side of things, these days there are a hell of a lot of, if you like, electronic black boxes. Now, one that does come with the software, if I have a look at ABB, basically these are what we call multi-terminal devices. It allows you to build any non-standard device, however the heck you want to build it or the customer wants you to build it. So you can have variable numbers of terminals, various bits of graphical and textual information. We're not forcing you to do things our way. And this is a prime example. Schweitzer Engineering in America had our software. We've got all their complicated Schweitzer protection and control relays, which can have 40 subcomponents, some of them. We had all of those, and then they were doing work for somebody up in East Palmerston, and the customer didn't want to have the Schweitzer relays like this. They wanted to do it like this SEL 451, prime example of a multi-terminal device. It looks like a PLC, but it's not. Now, again, while I'm in here, I've already pointed out that eBase can modify multiple drawings information external to the CAD session. But even inside the CAD session, we've got a very useful tool. If I go attribute edit on that push button, I could go and modify the information. Again, it's a slow process, but if I have a look down there, there's my East Palmerston. If I go back to my global editor, I just right click with my mouse, and it looks like what I showed with eBase outside the CAD session, but this is inside the CAD session, so only pertaining to this drawing. It's grabbed everything on this drawing, and there's miscellaneous and East Palmerston. I can go and change that to say, "G'day from New Zealand." And you will see in a couple of ticks, it's changed it as well. So both inside and outside, we've got tools to make modification of information far smarter. All right, now the next thing I want to do is go back to screen number 2. So I've covered all of that. I also point out, not only do we check for duplication errors, but, if you're using one of those relays with 40 subcomponents and you've used up 39 of them, it'll warn you if you've only got one left and you've used them all up. So that's useful as well. Okay, reports. Now, this is probably, again, saying it to you guys, probably the biggest gripe I hear about AutoCAD Electrical still to this day is trying to customize things in AutoCAD Electrical. And the biggest gripe of those gripes is trying to customize reports. It's pretty well near impossible as far as I've been told. But just like everything else, we keep our reports flexible. People can customize the order that columns appear in, etc. They can add extra columns if they want to. We also automatically can produce some of the reports automatically onto drawings. So you get your bill of materials, your quantities. Point of difference, we call it a multi-core cable in the rest of the English-speaking world. America calls them multi-conductor cables. We produce from to wireless for both your cables and your cable cores or conductors. I haven't found a machine yet that can't take the output from those and use that to produce labels for all your conductors. You might bring drawings into a project later on and you do have two PB2s or two PB1s. Well, it will warn you, so it's easy to track them down because we've got navigation tools to go and find them and change things very quickly as well. So, and it will produce let you know if you've got any short circuits or open circuits, duplications, and a few more. Now, revision, comparison, and drawing index report, I'm going to jump back to my CAD session. And that is because they're quite useful. The drawing index report is where our data mapping started. It's basically title block information. So let me go back to the other screen. And if I go back to the other screen, now drawing index report, one of the things you'll see in preference here is title block patterns. Because people wanted to produce title block information, which is usually project name, who did it. It might have the company logo, dates and things like that. But if they've got intelligent title blocks, we don't know what the heck they were called. So the title block pattern maker enables us to find that information. And if I go back to setup option, let's cancel that, sorry, go back to eBase. we have revision reports and drawing index reports. So check that on. The title block information, as long as you've defined the pattern, will produce the title block information as a drawing index report. Now, revision tracking, this is also another useful thing. We can link in with document management packages. Some are easier than others, but we also gone a little bit down that process ourselves. If you've got revision reports on, if you go to the project and you change from A to B or 1 to 2, what it will automatically do, it will archive both your old drawings and your old reports, and it will produce additional reports for any deletions, additions, or modifications. So it's easy to see what's been added, deleted, or changed. While I'm in here, I do tend to show, just to explain another thing. So the data mapping started with our title blocks, and it ended up with us being able to map information to CADWorks P&ID. The other point I'll make while I'm in here again is the fact that we've got if you encounter someone with MicroStation or that needs the output in a GGN file, we can convert to an automatic DGN file. It's what's called a block in AutoCAD, is called a cell in MicroStation, so we can convert to MicroStation without any loss of intelligence. So you don't have to buy MicroStation there. But that's by the by. So let me get back to the other screen again. Fully automatic diagrams. Okay, on the right-hand side, you can see an example of one of those big protection and control drawings I talked about from Schweitzer, where basically it pulls a pictorial representation of how things got connected, what wires or cables go into what terminals of the device, and what wires or cables come out of them. So it's, as I say, it's useful for people that actually manufacture things if this is generated automatically. As a bloke to me said in America once, now I've got to find a wireman that can read. But there you go. Again, terminal strips, huge time saver. I'm sure you've seen that in instrumentation, but I had a customer in Melbourne, Australia, who generated 700, terminal strips from 700 drawings in 20 minutes while he was away at lunch. We've got tools to go and do modifications. You can split terminal strips up. You can have them what we call polarized terminals. On that one, I've got cables on the right-hand side of the left-hand terminal strip, cables on the left-hand side of the right-hand terminal strip. So things like the flexibility point comes to mind as well there. That's an important part. PLC I/O cards, again, we've got some very powerful tools to go and produce I/O cards. And in fact, we can make it even quicker with the next thing I'm going to talk about. Cross-reference back annotation. Now, if I was doing a very big, one of those big Schweitzer relays, I probably wouldn't want to do the cross-referencing on the same page as the actual electrical schematic was being, because it might be bigger than the drawing. So again, it's flexible in terms of how you do cross-referencing. If you've got a simple little motor starter with a couple of normally open and normally closed contacts, you can have the cross-referencing appearing below or besides the coil. But again, as I say, if you've got a small drawing and a big terminal, big wiring diagram, you can do it on a completely separate sheet. Any of our reports, like bill of materials from to wire and cable list, can automatically be loaded onto drawings as well, and the order of which the columns appear can be changed. And we can also automatically produce cable conductor sheets, which I'll show in the presentation as well. Protogen. Protogen is probably the biggest wow factor of any of the modules that come with Elecdes. A typical example is Jacobs Engineering, which, well, it was Norman Disney Young, but Jacobs Engineering in Australia did 900 I/O drawings in 19 minutes for a tunnel project underneath the streets of Sydney, Australia. Another bloke I know, Worley Parsons, Worley Consultants in Australia, they were building desalination plants. They budgeted 800 hours to generate terminal strips, to generate loop diagrams, and 4 people. The smartest guy I never trained. I sent what I'm about to show you to him, and he did the work by himself in 116 hours instead of 800 hours. The other example is Yokogawa. One guy there did 2,000 I/O drawings, 2,000 I/O drawings by himself in a week. But how Protogen works, the other point I want to make is it can be used for any repetitive drawing situation. In fact, my first sale that I ever made in Texas was in the late 90s. I sold our software to a company that makes concrete water tanks, no electrical design whatsoever, just one hell of a lot of repetitive drawings. Now, how it works is it's sort of like the grandchild of Instrument Manager, I guess, somewhat simplistic grandchild. But basically, if you've got any repetitive drawings, you can define things that do tend to change as database fields by following that little formula there. Hash, field name, hash. or you could go hash field name, field width, field number. If you don't define the field width and number, it might make title 1 column 1 and title 2 column 50. But if you do define the field width and order, you only have to do it once. So that might have been already done on another drawing. You don't have to put in title 343 the next time you want to have whatever information is in there. So there's my title 1, title 2, etc. So basically you can fill in the information or have a macro do it for you. That's what Jacobs did in Australia. They wrote a macro to suck information out of existing Excel spreadsheets for IO card addresses, wrote a macro to dump it into the right place in ours, and out popped the drawings at the end. The problem that we had, though, was IO cards. In the old days, we would have one template. So basically, the standard AutoCAD drawing files that are produced, so basically, if you had to do some changes, you could open up the drawing and do the changes. So as I say, IO cards, while the cards are the same from drawing to drawing, the inputs and the outputs tend to vary. You might find that the first terminal on the first IO card is not used. It's a spare. On the second IO card, you might find the first terminal going to a proximity switch. So in the old days, like the Yokogawa guy I've got up there, he'd have to go and open up the drawing and change the spare into a proximity switch. Well, no longer, because now you can build composite drawings from a set of sub-assemblies. And the easiest way is to show you. So what I'm going to do is to go over to my other screen and get back into my CAD session. And I'll just erase, enter all on here. And in fact, I'll close that other thing down as well. That, by the way, that is an example of a real world drawing, not some of the simplistic stuff that I'm going to show in the rest of this. So let's get out of there. And if I have a look, as I say, Protogen, the important point I want to make is, if I have a look in my Elecdes installation, you can see that one of the, we have imp directories for all the imperial, feet and inches scale symbols, and met for all the other ones. Imp samp is the standard default, where I can find it. That's where you put all the template drawings for Protogen. Okay, let's close that out of there. So imp samp, and you can see I've got this here. This is just to show you how it works. I'm not only going to produce drawings here, I'm going to do that in a couple of minutes, but this is just to give you an idea of how things work. So let's have a look at sub 1. And what you can see, this is actually a loop diagram, but what you can see, I've got 3 instruments there, and then I've got conduit, hash conduit number 1. So that's just dumb AutoCAD text, but there will be a field in a database called conduit number 1. If I go AE, that's somewhat redundant AutoCAD command to have a look at one of the blocks for the terminals. You can see I've got the location panel number defined, a few other things. Now, the point I want to make here is, again, don't forget global editor, because I can click on this. When you're building these templates, if I go to my terminals, I can just go Control C, for example, by highlighting something, or like panel number, Control C, and then Control V all the way down. So there's tools to speed up the production of these templates as well. But that's a little sub-assembly out in the field. I've got 4 instruments on that one. Just a few other things to show you. The other templates. Then I've got another template that's got 4 instruments in that little box there. And the final one's only got 2. There it is. Okay, so I show that. And then the next one, we've got a junction box, and there's another point of difference. We might call it well, we do call it a screen. You call it a shield in America. I've got rack number, slot number for a PLC in there as well. And then if I have a look at the other one, okay, there's one without a screen or a shield. So there's some sub-assemblies. So I've got all these, just a couple more to show people. So they wanted to have things like field location, junction box name, marshalling panel name, etc. So I've got a few more variables in there. So I've got all these sub-assemblies. How do we combine them all together into a composite drawing? Well, that's where my title block comes in. If I look in down the bottom there, I can see this is done for a company in Murray, Utah. But I've got title 1, title 2, title 3, title 4 with the field width in order to find. If I wanted to, I happen to know that the value in the title 4 field is Phoenix, Arizona. If I want to have Phoenix, Arizona appear somewhere else, I just go hash title 4 hash. But the key thing is up on the top left there, if I have a look, I've got hash underscore origin and hash underscore origin 4. Hash underscore text or coordinates is a flag to say insert stuff relative to me. What am I talking about? Well, let me show you. Protogen, as I say, comes with the software. And if I go and open this up, okay, there's my master database file, and there's my Title 1, Title 2, Title 3, Title 4. There's my City of Phoenix. Now, again, I could right-click my mouse and go and add another 500 records, add records in there, but I'm not going to do it here because it's just to show the principles of how Protogen works. So we've got, there's my master template with 3 drawings. Now, because we've got this relational structure now, go to my sub-template. Just remember the top drawing is 2011. So go to my sub-database. And for drawing 2011 at that underscore origin point, which remember is just there, it's going to insert sub 1. And just to refresh your memory as what the sub 1 was, if I have a look here, there's my sub 1. And you can see there's my conduit number 1 and 2. And if I move this down and go over to the right-hand side, I can see conduit number 1 is 3330-3, 3330-4. Now, what I do is I go back to my master, go to my master database file, and I'll close these down because you don't actually have them open when you're generating drawings in Protogen. But just to reinforce the fact that I'd go transfer between drawings and selected records, and rather than having all this messy looking stuff, if I open up the example of the outputs, what you can see is drawing 2011. There it is with my 3330-3 and 4, my City of Phoenix. So basically, I've defined variables as database fields, and I could build composite drawings. If I have a look at another one, I've got 3 circles, 3 instruments in that yellow box. That one's got 4, for example. So that's the principle of Protogen. And now I've shown that, I'm now going to close this down. Now, there's a couple of things here. People do love this thing, and I do have an example which I've sent to you, MCC Builder. We had a company in, do you wish to write there? We had this company in, I think it was in Tennessee. They were building modular MCC panels. They wanted to do single line electrical drawings, the detailed protection and control schematics, and in fact the panel layout in 3D. Which panelists can do if you do put the information in. So we built an access front end for them, and the easiest way is to show this. First of all, if I go into my, have a look on my D drive, there's my EDS ImpSamp directory. And if I go to my one line master, now what you can see if I zoom in there, there's my #_origin. Remember, it's a flag to say insert stuff relative to me. What sort of stuff? Well, let's have a look. I say it was modular. So the modules that they had, there's the 20 amp one. And there you can see I've got CCT, which stands for circuit number, defined as a database field, column compartment names, and all that sort of thing as well. Okay, so there's that. That's one of the sub-assemblies. And then I'll just cycle through a few of the others. There's metering. You can see it change in the little preview, 100, 200, 350, 70, and of course the power supply. So there's those. Okay, let's close that down. We'll file new, better get it up and running. Okay, the next thing is the panel layouts. As I say, Panel.des does work. And you can see there's, I've got my #_origin in model space. If I have a look at, I'll open up a couple of modules here. There's my 20 amp module. If I zoom in, I can see I've got a little couple of terminals defined in there. I'll close that one down though. And then again, cycle through a few of these. There's metering, 100 amps, 200, 350, and 70, and my power supply. I'll open up the 350 just to show there's a whole lot more terminals stacked in that one than there was before. Just a couple more other things to show. Let's close that down. Schematics. Now, if I have a look at my schematics, it's a D-size sheet. So there's my schematic master with my #_origin in there. The sub-modules. Now, this is actually illustrates a useful little point, reduction of the number of fields in the database. Here you can see I've got WY, WY plus 1, and WY plus 2. We had a customer that had 500 wires on a drawing or some ridiculous number, but it was always just going W1, 2, 3, W1, W1, 2, W3, W4. They said, we don't want to have 500 fields in the database. Point is, it doesn't have to. If the value in the wire field is 400, it would come back in the drawing as W400. 401, 402, 404, etc. So you can reduce the number of fields in the database that Protogen uses if you've got some simple implementation step. Okay, let's close that one down. And then again, I'll just cycle through a few of these. There's metering, 100 amps, 200, 350, 70 power supply. Let's open up the 350 again, because you can see it's a lot more complicated. But there's a fine example there. And then the only other thing that I wanted to show is we automatically generate wiring diagrams, and we've actually set up wiring diagram place markers as well. So if I have a look at my wiring diagram master, I can see there's my #origin. And again, if I go, there's my wiring diagram 20, and these are the little place markers. And again, if I open up, I'll go cycle through them rather. Metering, 100 amps, 200, 350, 70 power supply. But let's open up the 350. You can see it's got a lot more markers in there. All right, now the next step is to go to my desktop. And for that, I will. Now, as I said, we built an Access front end, and I can send this. I talked about the Australian guy that did 800 hours of work in 116 hours. I sent him this. He customized it for himself, and he's the one that did did the work in 116 hours by himself rather than with 3 other people. Okay, so we said, as I say, this Access front end, and the easiest way is to show you. I'll go. I'll make the first one USA. Oh, sorry, capitals. Let's make it 1 USA exclamation mark star. So just remember the first 3: 1 USA exclamation mark star, 1A, and 1E. Exit from there. And then I also explained that there's all those the modules that I was just cycling through. So it's like that. Tiering compartments like a row and column. So where in 3D space of this panel is it going to lie? I also have a look at the parameters. For example, I've got it going onto my C drive here. I've got 5 single lines 4 inches apart. We do have a metric version of this as well for Jerry Lee. But anyway, so I've got that. And then I can just quickly go dump to Protogen. I used to be able to go and grab a drink, but it doesn't work so quickly. It goes too quick now. Now, I have just made about 45 drawings, and the easiest way is to show you. If I have a look on my C drive, and there's my EDS sample drawings, and I point out all of these drawings I have just made. Okay, now the preview doesn't look like a single line, but when I open it up, you can see 1 USA exclamation mark star. If I have a look at my panel layout, pretty impressive this, I reckon. There you can see there's my modular MCC panel with the modules put into the big enclosure. Means we can work at accurate wire lengths and things for that. Close that down. Let's have a look at, I'll close that one down while I'm here as well. Let's have a look at one of the schematics. I'll open up my schematic number 16 because I know that's the 350 volt one that I showed before. And there you can see there's my wires 411 for basically wiring goes from top to bottom or left to right, your definition. So it's done all my wire numbering. Let's close that down. Now, as I say, if I have a look here, this is the other thing that's a bit of a wow factor, WD16. There's all my wire place markers. If I just go WDE for wiring diagram editor on the command line, and there it's found, picks the right drawing, as if by magic. There is my wiring diagrams. Now, as I say, that's a pretty big wow factor. Now, while I'm showing them that, I also will open up another drawing. This is one of the 2 things that does not come with the software yet as a default, but it's a pretty powerful tool. The other thing is if I open up, let's go back to my right directory, somewhere when I get to my D drive, drawings for demos, Imperial, and demo recording. What I have also got here is a US drawing example. Now, this is the sort of thing that I produce at the end of my drawing sessions. And this is used, this PLC broken up into 3 parts was produced using my PLC IO card generator. But the point was Protogen, it's pretty fast as it is, but Protogen can make it even faster because if I have a look, let's close this down now. I have got an example of US PLC and then my IMP samp. AI analog input, AO analog output, DI digital input, DO digital output. Let's have a look at an AI16. You can see now it looks similar to what I just showed you, but I've got rack slot channel numbers defined. I've got sub-assemblies for inputs and outputs. Let's have a look at one wire. There's one for that. And so again, so I've got that, and it can be extremely efficient because now if I have a look at the sort of output that's produced, you can see we've got those sort of things in there. Or I'll go and open up another one. And so there's whole lots of things. So again, the production of drawings becomes a data entry exercise. It is very efficient. Now that is pleasant. It does not come with our software. Neither of those things do, but we can send them to people as I have sent them to you. The other thing to point out is that now we can work with native Excel files, so you don't even have to write macros necessarily. And I've also sent you the example with instructions for that. Okay, let's get back to the other screen. Okay, so that was Protogen. Pretty powerful tool. It is a huge selling factor in its own right. 900 drawings in 19 minutes. You find me another company that can do that with a PC-based CAD file. The cable, did I get that right? Yeah, I did. Okay, cable scheduler. Now, I was going to show you the latest thing, which where we can we were supposedly going to have a two-way directional link to cable scheduler. In other words, if you changed information in the cable scheduler, it would update the drawing. If you changed information on the drawing, it would update the cable scheduler. However, Rob the idiot, being the idiot of the organization, discovered that it only works in one direction, from cable scheduler to drawing. So what I'm showing you now is what I would normally show in terms of just my normal cable scheduler, the old style, before the being able to modify information as well. Hopefully that'll be fixed soon. But the key thing is, as I say, single lines and block cable diagrams, they have one thing in common. You won't find a terminal on a drawing. So it's impossible to produce a detailed from to cable list, because a detailed from to cable list will say which conductor or core goes from what terminal for example, a terminal strip in a panel to what terminal on a device. And as I say, terminals are not located on single lines or block cable diagrams. We originally did this again for GE, Alstom in the UK, as they were before they became GE. And what they were doing, didn't want to do a detailed schematic. They would go to site, they would do a single line drawing, and based on the equipment's location on site, that was how they would bundle the wires together as to cables. And this enables them to do that. So the easiest way is to show you. It also does modulus cable routing, but that's something that Andy shows in his presentation. So easiest way, again, let's go back to drawing screen number 1. For this, I have to go back to my normal mode of just Imperial. So let's go okay to that. I also at the stage while I'm here, by the way, I point out that we do have our license manager while I'm changing things. And you can I will send a demonstration site where you can use evaluation codes to have a play with the software. I'll come back to that in a little bit of time. I also point out that it's floating network license. You don't pay any more for network licensing, but if you've got 11 copies of the software and you've installed it on 100 computers on your network, the 12th guy's going to have to wait till the 11th one gets off. All right, let's get out of there, minimize that again. And let's open up my CAD session again. Okay, for this, let's go and have a look at my CBD schedule. Now, this is a block cable diagram. You can see I've got some motors, single line cable motors, HEJB, single line cable motors, terminal box again. Okay, now if I use my global editor on this, I can see, for example, if I follow the H201, let's have a look at the H201 cable. I can tell that behind the scenes, if I go catalog select, that has got 4 cores or conductors. So there's some intelligence behind the scenes. But what you won't see, if I go onto my terminals, no components of this class because they're not on there. Miscellaneous, on the other hand, there are some. If I go field, let's make it field NZ. There you go, just to change something, to prove that it's there. Yep. And if I have a look there, it is field NZ now. Okay, but the other thing to point out is, get back out of there, eBase. My little project manager's got to know what to look at. By the way, while I'm here, I'll show you I've got those drawings to database and database drawing buttons grayed out. Again, we do have a database editor, which I'll come back to, which can open up SQL Server, Access, Excel, and DBF files. The key, though, is if I go to Setup, I can go to Preferences and go Manual Image Update. What that does, when I open it up again, is if I have a look at eBase, those two buttons are no longer grayed out. So, for example, designers could do the drawing using the drawing tools that I show pretty quickly with minimal information. They can then use that drawings to database button to export out to a database, and engineers or costing department people can go and use the tools they're familiar with, not ours necessarily, like SQL Server Access, modify the information externally using those tools, and then give it back to the designer to load it back onto the drawings. But for the purpose of this presentation, I will turn that off because it's less button clicks. So turn that off. All right, now again, eBase, let's go and get the project, load to create the project in the right place here, which is somewhere here is, where is it? I'll get here. D drive, drawings for demos, aerial. Okay, and let's go and find, there's my, no. And there you can see I've got the single line drawing, and that's the one I just showed you. I do have a metric version of this as well, but I go to that now. As you know, cable scheduler and instrument manager have been modified, but for people that have seen electrical, this is the data-centric side of electrical. So I open up this, create or open project. I'll go next, and again, I'm going to use Microsoft Access. And what it's done is there is my, let's go and put this, make this bigger. And if I have a look here, there's all my devices, areas, closures, aux JB there. So if I have a look back at the drawing, just to reinforce the fact, there's my aux JB, my HEJB, and all those sorts of things. Let's go back into here. If I have a look at cables, there's my H201. You can see it's already got its 4 conductors in there. My SL100 has got a few more. If I have a look, SL100 is between the 2 junction boxes. So if I can go and select, if I go and have a look at my devices, HE1, you can see I've already assigned terminals to it. But again, I can select from catalog, or I can go and add terminals by clicking on device terminals as well. But the other thing I want to do to show you how things work is I want to put some terminal strips, 2 terminal strips, one of which is going to be an HEJB and one of which is going to be an aux JB. So go back to here, and if I go add, again with the 2-way database link, I can spec it at any time, but I'll pick a particular sort of terminal, go okay to that. Tell me how many terminals I want on my terminal strip, create all and close, and just go no to all there. And if I have a look, there's my TB1 with its 30 terminals. Now I can right click with my mouse and say pick parent. I want to put this in my HEJB, which I can go okay. And if I go up the top and go to my enclosures and have a look at my HEJB, I can see it's now got TB1 in it. Okay, if I look at aux JB, there's other things I can do here as well. There's more than one way to do most things. Add new terminal strip. I'll just go okay to that, putting in terminal strips as well. And I'll just go create all and close. And you can see I've got TB1 and TB2. Okay, so you can add termination, so you can actually physically hook up the cables, which is what we're going to do now. So the sync buttons is what we're supposed to sync with drawings, but it's not working properly yet, so I'll delay that at the moment. Connection view. Okay, first of all, let's go and have a look at my terminal strips. There they are there. All my cables and wires. There's my cables, and there's all my devices. All right, there's my H201. Okay, now on one side, I've got, it's connected there to my HE2. But on the other side, I want to run it into my terminal strip. So let's go H201 onto HE2, connect and close. And you can see now there's 4 conductors, so I only had 2, but that's to show it finds mistakes as well. So I had a 4-conductor cable, but I only had 2 terminals on that device, so there's 2 spare there. On the other side, I want to run H201 into my HEJB TB1. I'll put it on the first, and it's connected. And the other one I had terminations for SL100. On one side, I'm going to run it into TB1, but I'll put it down about here. And on the other side, I'm going to run it into TB2. Okay, so I've connected things up. As I say, I can now do what I was designed to do for generate EDS reports. And this is where it'll have a look and tell me any things it finds wrong. Like, oh, and it's putting it on the wrong screen. So let me move this across to the other screen for you. It's found open circuits, all that sort of things, catalog mismatches. But from not very much, if I go back to my database editor, I can open up a database file and a D2 cable core schedule. And here you can see HE2 terminals 1 and 2 goes via the cable to my other end. They made a bit of a mistake on this, but I've got to get it fixed. And a point to make is if I then close that down and go into my CAD session, close this down, go File, New. I'll put in a C-size drawing again. And if I go into my terminal strip wiring diagram generator, the things that I've defined, which is TB1, TB2, HE2. Okay, so, that's pretty wow factor for people because that information wasn't available on the original drawing. So being able to do this by just adding terminations is pretty useful as well. All right, so that's a little example of cable scheduler. Let's close that fella down. And I'll just go File, New for the rest of this demo. And if I share my other screen, okay, cable scheduler, sorry, that was cable scheduler. The next one down here is Elecdes assemblies. This is the last thing that was added to Elecdes. We already had something a bit similar in Paneldes Raceway, where you could save a section of trench with all the mechanical sub-assemblies for future use. But we also had the same customer that asked us for our multi-client library manager, which allows you to set up drawing parameters for different clients. They were doing both single lines and the associated detailed protection and control drawings. Now, if you put them in the same project as you're liable to, it would come up, number one, it would come up with a duplication error. The other thing they wanted to do is they had simple sub-circuits that they wanted to be able to save and use in future. And as I say, it's a good idea. It took a while to get it done, but it's there now. So the easiest way is to show you again. If I go to screen number 1, and first of all, let's open up that US example drawing again, because this shows you how to build these assemblies. US example. There's a little motor circuit on the right, on the left-hand side there. R1, R2 with motor starter, motor reversing, contacts, wires and things. I could use that again. Now, while I'm in here, I'll just point out, if I have a look at my IMP assembly, that's the new subdirectory where it puts the drawing, any assemblies that you create. How do I create an assembly? Pretty darned easy. Create, click on that, draw a window around what you want to save, making sure you've got it all. And then I've got them on down the bottom. It says select objects, right click, pick the insertion point. I can type end there, and then it's going to ask me there. It goes to assembly. You give it a name, it's saved. Pretty simple. Takes 2 minutes to actually save a sub-circuit. Okay, now to see it a little bit in use, keeping it simple again. Okay, first of all, let's open up a couple of drawings. SE1, which is just a single horizontal line, and SE2, which is a single 3-phase line. Now, the other thing is, again, it's worthwhile pointing out, everything I do inside can also be done, or outside the CAD session, can also be done inside, including eBase. I've got a project with these little drawings defined, D3, go into that, and there's my two drawings. So it's got to know what to look at. Go OK to that, exit, and now, again, if I go back to my first drawing, let's go and insert an assembly, and I'll go and pick my three-phase motor single line, and OK to that. And if I zoom in there, you can see, I'll zoom in so you can see it's M1. Now, again, I can go to assembly 2, and the first thing I can do here now is I go reference the other drawing in the project, assembly 1, and there. And now I'm going to pick a three-phase motor to put that into there, and go OK to that. And now if I have a look, there's M1. And if I go AE on this and change that to M1 Hexagon, lo and behold, when I go back to the other drawing, it's now M1 Hexagon as well. So if you change one, it changes the other, and it won't think it's a duplication error. So that's another useful tool. Now, again, that was the last slide, just to reinforce things. The key things about our software, I'd say, number one is a two-way database link. Number two is definitely flexibility, trying not to force you to do things our way, and let you do it how you want to do it, or more particularly for consultants, how the client wants the consultant to do it. All right, now I go back to the other screen, and this is where I now go into a bit of setup, explaining a few things here. Okay, setup, I've already indicated, you've got your Imperial, all those sort of things. I then go into here. Warnings, there's a whole lot of things you can check for. If you're doing initial design, you just chuck things out quickly, you can turn a lot of those warnings off. Report preferences. Now, again, when I generate a from to wire and cable list, that's what I'll put between the cable and the terminal. You can change that. I always indicate this as well because it's a valuable point. I mean, we try and look after people. We're certainly not afraid of helping, and I'm sure people go to Hexagon for help as well. But I'd say, what's this hybrid thing? Well, hybrids, because every project that you're going to find is not going to be a greenfield project. And we built hybrids because we had a customer in Australia that had some drawings from the 1980s, I think it was, and they were big drawings, a E-size sheet, I think it is in America, A0 in metric. They'd scanned them all, so they had these scanned raster files, but they didn't want to redo the whole thing. So a hybrid is like it's an overlay that you can hybrid strip terminal, or a device terminal, a pin. So you can overlay that on a scanned raster file, and it acts as a start point for intelligence, which is actually quite useful. Now, the point I want to make that is help. If you get stuck on something, the first thing you should go and have a look at is the help that's found with the software. If I type hybrid, how to connect to equipment that is not in a project. So there it goes into a bit more detail about it. I point out point 2 is that don't be hesitate to contact us, contact me or contact Hexagon for help. I also at this stage point out a couple of other things. Do you wish to view the metric movies? No displays Imperial, so I'd go no in this case. And there are little schematic circuits. These movies don't have any sound, but they give a useful feel for how things work. So you can watch these movies to your heart's content. Anyway, that's that. I'll close that down now, and let's get back to setup. I do want to go through all of these things normally. So as I say, report preferences, hybrids, variables, catalogs. Now I point out that your catalogs can reside in SQL Server, Microsoft Access, or DBF files, depending on what level of what you want to reveal to customers. I also point out we have make catalog, edit catalog. It actually can be a positive selling point because some of the competitors like AutoCAD Electrical have got hundreds of thousands of obsolete or not commonly used components or with different part numbers. So we can allow you or help with the assist with the building of catalogs specific to a customer need. We are looking at adding a lot of external catalogs at the moment, as you probably well know. I'm sure David's discussed that with you in the past. Okay, so back to setup. Administration, as I say, I point out that the fact of the matter is a two-way database link is an extremely powerful tool, but can also be a dangerous one. I always remember in the UK seeing 10 blokes working on their own version of exactly the same thing. So what we tend to do is have an administrator who can, for example, say who can access catalogs so that people can't just add devices willy-nilly and things get out of sync. Administration is an important thing. Directories, now here you're going to take an example to have a dig at AutoCAD. We've got report templates, ODBC templates, try and customize one of their reports. I also explain that, if you've got if I look at metric samples, because I know I've got this, metric prototypes, browse, and what you can see here is I've got metsamp Elsmore. So, you could build up subdirectories of Protogen templates for particular clients as well. Flexibilities, our middle name. Preferences. Now, this is actually quite useful, and it kills a couple of birds with one stone. Names ANSI, names IEC. Preferences. All right, so let's get out of there. I don't know what the hell. There we go. And what this is, this opens up the names ANSI file, which is found in Elecdes, and it's a database file, but it does a few things. Number one, it defines how things are named. When I first inserted the push button, it came up with PB1 as the next option. PB2 would be the next one if I hadn't already put it on my drawings. So number one, how I name things. If I want to have it going PB1, PB2, PB3, I leave it like that. If I want to have it going PB1-1, PB1-2, PB1-3, I do it like that. And PB1-A, PB1-B, I do it like that. So number one, how you name things. Number two, it tells our software what they are. You might want to build a strange new push button for Hexagon. You stick your new block name for your new push button on the same line as all the other, if I could type, of course, as all the other push buttons. And so it's an identifier. It knows that it's a push button and not a fuse. So number one, how you name things. Number two, what they are. Number three, default column. You could be working on more than one project for conceivably with different naming parameters for more than one client. When you turn your computer off at the end of the day, it'll store your last name in that default column there. And we've got all the normal data editing tools, cut, copy, find, and replace, all that sort of thing. Now, I leave this open because there is another thing I want to go to, which in setup, zones, which is particular to the American market. So I'll just leave that open and go back to setup. If I go to preferences, first of all, no, actually before that, I'll actually close this down now. I'll come back to preferences at the end as a rule. I'll just leave the thing open there. To give people an understanding of how the software works, I think I have to actually say that. No. That's, yeah, right. I should have just opened up in the database. Okay, but to give people an understanding of how things work, yeah, this is what I'd normally do. I'll just come back into here. I'll reinforce where it's located anyway. Elecdes, and there's my name's ANSI. There it is there. So that's where it came up from there. All right, and I'll leave that open. But again, let's go back. So I'll come back to the other preferences. But the other thing I want to point out is tutorials. Now, because of COVID, of course, we couldn't travel, so we've got web-based training. But these tutorials are pretty useful for giving you initial understanding of how things work. We've already got, if I have a look at my license manager, you can type in the monthly evaluation codes. I wish to use an evaluation code. That's where you type it in. So I explain that to a customer as well. But then if I go into here, I do tend to play this first little movie. No, I use the Imperial ones. Do you wish to? Yes, I do. Now, they're little screen capture movies, and unlike the new web-based training, they do not have any exercise to check your own progress, and they do not have any sound, but they're quite short movies, and they do give a pretty good basic understanding of how things work. So I do tend to play this first movie and watch what it does. I just hit the fast forward button. In this particular case here, it's going to go into Elecdes. It's going to sometime before Christmas. It's going to go up to Elecdes there. It's going to go to insert borders. And in this case, it's going to pick a C-size border. Now, I hit the pause button there initially because I often get people that complain to me. They say, in our Imperial Borders directory, I don't like your style of border. I know of not one customer, not one, in the many years I've been here, that uses our borders out of the box. This is where you put your own borders if you're a manufacturer, or if you're a consultant, your client's borders. If they're feet and inches, you put them in imperial borders. If they're metric, you put them in the met borders subdirectory. The only thing you got to worry about is when you put in your own border is that your 0 point is the bottom left, as this will show you. Borders are automatically inserted at 0. So what you do is, as I explained to the client, you go into your CAD session, you go Elecdes, drawing macros, insert border, and pick a C-size border. In other words, duplicate what you've just seen. Now, this is the point I want to make. So there's that, and then I'd say, and then you go, no, sorry. And then you go on to the next movie, and it goes in a logical progression. Now, there's Protogen, for example. Protogen in its original form, where you could only have one template. I do point out to any electrical guy as well, because most electrical companies are finding standardization as a key as well. For example, AC and DC schematics, the Schweitzer Engineerings of this world, for their substations, they're doing standardized AC and DC schematics. So I point out to them that even if you don't do instrumentation, check out the day 2 tutorials, because they show you how a Protogen works with sub-templates and build composite drawings from a set of sub-assemblies. There are also other tutorials on things like customization, the whole 9 yards, basically. So as I say, I'll point that out to people. And now I go back to, there's my little border. The first thing I want to point out is let's get back outside my CAD session. And if I go to Setup and go to Preferences, Cross-Reference. All right. Okay. Now, what you can see here is I've got rows equals letters, columns equals number, which is great. But flexibility is our middle name. They might have a client that wants us to have rows equals letters and columns equals letters. All right, goodbye, columns equals numbers. Columns equals letters it is. So point number one is, say, it's flexible in terms of that. And if I have a look, there's my options. At the moment, just remember there's the 2. Point number 2, cancel that, as I've shown you before, but it's worth reinforcing some things a few times. Everything I do outside can also be done inside. If I have a look at cross-ref preferences, there's my options again, and there's my 2. Now, what that 2 refers to is my grid spacing. I've got a 2-inch grid between my E, F, G, H, and I, etc. I think it's 100 mils in the metric version. So if I want to change it to 4, you just change it to 4 there. The other thing that I want to point out here is for the American market in particular, I personally think that it is just making life more work for yourself, but then sometimes you're customer driven, because we have tools to go and track things down automatically anyway. But let me just enter that and erase the border. And if I go Elecdes, cross-reference, place array of rungs or zones or rung numbers, 25 columns, 25 rows, 2 columns rather, put it up there, put it back there. And what you can see, it's put in line numbers when it's finished. Okay, now that's the point. As I say, in America in particular, they tend to do this rather than the XY coordinate system. And that's why if I come back here, zones. Okay, if you want to have the line number included in the, I can just go dash, included in the device name. So the first coil on line 100 would be R100-1. The second coil on line 100 would be R100-2. Same story for internal panel wiring. So again, I'm trying to reinforce the fact we're flexible. You can have the line number included in the wire name. Quite a common thing to do, but I personally think it's just making more work for yourself. But if you've got to do it, we've got the ability to enable you to do it. Okay, let's close that down now and go no. All right, and erase. All right, so now I go into the drawing side of things. And for that, the first thing I want to do is to go File, Save As. And we're going to save this as drawing number 1. Now, I've saved it as drawing number 1, and now I'm going to go and put in a decent sized border, A1 or a D size in American speak. Okay, there's my D size border. Okay, the first thing now, as I say, I've shown this. Some drafters can get a bit antsy, no question. Engineers, often at this stage, they'll leave. But then I've quite often found that engineers, as I say, have no idea that the tools that we've got for drafting compared to their manual way that their drafters are doing things currently, inserting a symbol, drawing a line for a conductor, moving the symbol, having to repair the lines. It is eating away at the amount of time and decreasing efficiencies by orders of magnitude. So engineers quite often want to see this sort of stuff as well. So first thing I do is I go and set up a, I've already showed you, it checks for duplication errors. So just to reinforce the fact, let's create a project called D3, D4 even, D4. Okay, yes, I do want to create it, and I'm going to add the drawing I've just saved. Okay, to that. Now, the reason I'm doing that is if I go now and draw a ladder, and again, some engineers go, wow, and some drafters will as well. Are they horizontal or vertical ladders? I'll pick vertical, pick the insertion point of the left rail, right rail, T to type the distance, I think 2 and inches. Oh, trouble is we don't use feet there. I got it right, 2 inches apart and 10 rungs. Now, again, the fact of the matter here is, and this is to reinforce the fact of what I've already showed them, if I go and put in push buttons, if I go M for multiple, you can see multiple down the bottom there, M for multiple. Oh, sorry, exit, wrong thing. Let's do it right, Rob. Push buttons, M for multiple. What I'm trying to do, just draw ortho, turn ortho on, F8 through there. Okay, and now again, so let's come up with my PB1, and unlike before when I inserted a PB1, it's not going to tell me I already had it because there's no other drawings to check against. And you can see now again how it's gone and incremented everything. That's pretty groovy and quite a common process. Now again, terminal strips. Okay, this is another thing. If I go M for multiple, just put that in there, draw a line through there. To generate terminal strips, there are 3 parameters: location, terminal strip number, and terminal number. With the two-way database link, I could spec it later on, but I can also spec it now. Okay, let's put those in there. And then again, we've got a whole lot of different terminal strips, terminals rather. Let's go and go M for multiple. Now, it doesn't count backwards. So if I change that to be panel 2, I do have to manually revert that back to number 1 there. But it is far quicker than having to go and insert everything out and then draw lines afterwards. So to do what I've just done there, and if I zoom in, okay, now the key factors are, this, as I say, we don't cut anyone out of the CAD sessions. We've got tools designed to make life easier. The number of times I've seen people write little list files to switch visibility on or off, we've done it for them. So I can click on that, and I'll put in the terminal block and the panel number as well. And you can see I put them in there. And there's other tools that say these sort of tools designers really like. If I go move the circuit, for example, if I grab that, it looks for association. So you can see it's grabbed everything on that rung. Now, again, that might, to you people that don't do electrical much, it's not that big a deal, but it's these sort of other little things that designers are going, wow, that's pretty groovy. That'll save me some time to play solitaire or something. If I go detext, and I can put this in here, and again, just put the style in there, get a form NZ. Okay, and then I'll just go, thank you very much. I'll save that little drawing, file, save, and then the drafter could now go and be doing something else. So I'll just go file new, so I've got a new CAD session starting up there. Okay, to that. And the point being is I can now go back into here and I can go to eBase, and this could be the costing department, global edit. Let's go and find my devices. All of my same manufacturer 100 amp push buttons, catalog select. Well, let's go and make them Telemechanique XACO2013, but you've got the tag name wrong. It should be PB500. Increment the tag name by 499. Okay, to that. And then go, I'll go and change something else. Here's something good. US cricket. We've been having cricket matches in the United States, and they're actually beating some good players. We're already out. Okay, there you go. Exit from there, safety changes. Now, again, what I'm doing is reinforcing the fact, because if I exit from there, if I go back into the CAD session and open it up again, we will see that US cricket is okay. But of course, what I also want to reinforcing things a few times. Don't forget global editor. It's much more likely that I can go to, if I go to my devices, and change those, same manufacturer, catalog select, I'll change them into Merlin Durand because I know it's got a 250 volt rating that you can see there. Okay to that, and I'll increment it by another 500. So it'll be 1000 onwards now. Okay to that, and let's go and change my miscellaneous to, hey, I can speak Texan, Chad. And it's changed it. So as I say, both inside and outside. Now this next little bit, there aren't too many consultants that don't do the three-phase side of things. So this is a little bit of a wow moment in terms of the drawing side of things as well. As far as I know, well, certainly people seem to like it. I don't know our competitors. So again, I picked the start method. I'm going to start this with, take it back to panel 1, terminal block 1, terminal number 1. Now, the point I want to make is I'm going to pick wire markers, circuit breaker, wire markers, isolator, wire markers, and auto drawing. In any of these auto drawing routines, if I pick a particular sort of thing, it will default to that sort until I change it. So again, I'm going to go pick wire markers first. I'll pick a 1102 wire. It'll default to 1102s until I change it to another sort. Circuit breaker. And again, if I go and find, I've got ampage in the first column there, find a 20 amp circuit breaker, and you can see it's keeping track. It's coming up with number 4, 5, and 6, and then my isolator AT1. It's going to make that a 20 amp one as well. Okay to that. 7, 8, 9. Okay to that. End order drawing. Where do I want to end it? Down there. How do I want to end it? So as I say, this does tend to impress drafters and engineers, the fact I can do that. I also reinforce the fact I could use my normal AutoCAD stretch command, or I can change the default setting. But I can also do this. So if you know what's going in your circuit, you can chuck them in as you go. I can also do this though, start it horizontally, construct corners or alter spacing. I'll alter my spacing first. I'll put in another circuit breaker so you can see it's counting up to CB2 and defaulting to the last one I used. Then go across to there, down to there, across to there, and across to there. And it amazes me what I do next. People love this as well. Because first of all, I say, so this, I can use this to go and, I'm just trying to work out my spacing on my drawing. I then go into my symbols, go and find a three-phase symbol and go and pick a Rob. The idiot can go and put an isolator in the wrong place. But don't forget, we've got all these powerful tools like move symbol, grab that. I'll move that down to there. And if I go move circuit again now, and what it does, and as I say, this is the bit that I'm amazed how many they go, God, that's amazing. Do that. All right, so there we go. Okay, then I go down to here, and the simple thing to do is to go and do a simplistic little motor circuit. And the reason I'm doing that, relays are devices that have subcomponents. You'll have a coil, normally open, normally closed contacts, and a few other things sometimes as well. So let's go back to there, my three-phase start again. I'm coming off the vertical line, so pick the appropriate start method, which is that one. And because I want to have motor starter and motor reversing contacts, I'm going to move it out a bit here. Now, again, if I pick the contacts, this is where I go into a bit of explanation about subcomponents. If I pick a 16397 subcomponents, you can see it's got subcomponents. The three-phase is subcomponent 1. Now, the point I want to make here is you don't want to see 4 separate records in the bill of materials when it's one physical device you buy from the wholesaler. So what we do is it will put the lowest subcomponents number 0. That's what it would put into the bill of materials. 1 coil, 1 three-phase, 1 normally open, 1 normally closed. Of course, to muddy the waters these days, you can get auxiliary clip-on contacts, which you do want to add to the cost. All we do in that case is we have an M for modular in the subcomponent field, and then it will add it to the bill of materials. We've been around a while. Now, in this case, I'm going to pick that. First of all, not save the changes, and it's going to say, hey, and again, a bit of error checking. You picked three-phase contacts, and you're selecting the information for a coil. So just reducing errors. Oops, yeah, I better check the right one there. Three-phase contact, okay to that. Don't want to save the changes though, and construct corners or alter spacing. And again, if I put in terminals, because I'm going to run it out to a motor, it remembers the last terminal was number 3, and it comes with 4, 5, and 6. Multi-conductor cables, we've added a whole lot of American type cables, y'all. If I have a look at Belden, I'll find a 3-conductor cable. There's that. Now, again, my generic catalogs, I do point out I do think it should be M rather than, it's the only thing I don't like in American naming. But if I have a look at my sample 100A motor, if in generic catalogs, if you give a catalog number, something that bears relevance to the device, it's useful for modification of stuff later on. Where you could change all my sample 100A MTRs in the database to a General Electric 100A motor, for example. Okay, and now again, I want to make this little fella go backwards. So again, how do I want to start it? Coming off the horizontal lines this time. Construct corners, alter spacing, down to there, across to there. Now again, I point out reduction of errors. I know I'm doing it on this drawing, but I might be on sheet 500. If I go and change it back to R1, it says, hang on a moment, it's only got one set of three-phase contacts and you've already inserted on that drawing there. So, oops, better not call it that. So again, reduction of errors, increasing in efficiencies. Okay, to that. Construct corners or alter spacing out to there, up to there, end auto drawing, reverse phases. Now, again, it's worthwhile showing because people like it. The groovy little move circuit thing, if I go move, put it up to there, it does it. I'll move it back again though. And the other thing I want to point out here is I've got wires 7, 8, 9. Now, internal panel wiring is different to a cable, which is running to something out in the field. You can actually, as long as it goes from top to bottom or left to right, you can do internal panel wiring at the end, as I say, as long as it follows that formula, top to bottom or left to right. But in this case here, I can also just draw a crossing. And what you'll see, the question mark, it's telling me that if you're going to do wire numbering on the drawings, make sure any other drawings that have already got wire numbers on them are included in the project. Well, we've only got the one, so yes. And you can see it comes up with wire number 10, which is obviously one from wire number 9. And there it is. Now, again, ZE. Escape. ZE. I might want to copy that circuit. Now, you showed me, Chad. I actually didn't know that. I use it from this way. In fact, again, I'll just use an M for move, using a few little AutoCAD commands or CAD commands. Sorry, I don't mean to say the opposition's name there. But there's my little circuit. Now, normal CAD, you'd copy that, and then you use attribute edit to change R1 and 2 to 3 and 4, 10, 11, 12, 13, 14, 15. I could copy it and then use my, don't forget my global editor. But I've also got the old copy circuit command up here. This is where I grab it, not from setup. Copy circuit, and click on that, and just move it down. And again, it's changed things. So that's quite impressive to most people. Okay, a couple more things to do on the drawing side of things. I want to convert to single phase, so which is common. So pick the first, pick my convert to transformer link to three-phase. One first three-phase line, second three-phase line, left rail, right rail, transformer sort that I just grab a generic transformer out of the catalog and put it down to there. So that's pretty groovy. Again, ladder to ladder transformers, quite common as well. Left rail, right rail. Okay, to that, put it in there, and then I just go U for undo because I'm going to put in a few rungs in there. So go back to my ladder. I want to put in some rungs in that little bit of ladder. So they are vertical rails, left rail, right rail, T to type the distance, 1.5, and I want 4 rungs. All right, now again, other things that make drafters and engineers go, that's cool. Insert subcomponent. As I say, relays, that's got 3-phase contacts, a coil normally open, normally closed. Subcomponent, I could click on that and it shows me what I've used, what I haven't used. But again, I might be on sheet 500 and I can't remember, where you can just right click with your mouse. I know they're all called something or other, star, wildcard, shows me what I've used, what I haven't used. But as I always point out to people, there's more than one way to skin a possum, flexibility being our middle name. I can go back into symbols here and also manually go and find relay and other coils. I can go M for multiple, draw a line through there, F8. And now again, if I go to R1, available. And then just to have a little circuit, it's a pretty stupid circuit, but again, it's just to show the point. I'll just go and put in some push buttons here because time is of the essence, of course. I already go on for too long. Okay, to all. Let's put those in there. And then I will also go and find my relay contacts because this is another useful one. Normally open contact, and I'll go and put this in there and find my R1. And there it is. Because this is the other thing that we have. Swap normally open for normally closed or subcomponent. It's more likely to swap for one normally open for another normally open, but in this case here, I can just quickly go and find my normally closed, and it's swapped them. Okay, another couple of things. This is useful in particular, insert from catalog is useful for manufacturers. They're always using the same sort of thing. They've got their own set of components, insert from catalog. And if I click on this, I'll go and generic devices. Let's go to Merlin Duran. Go Merlin Duran and click in here. Sorry. And I'll type in 1513. And you can see it's filtered it down to my 136 and 137. So it's a database filter. I say it's actually quite useful as well. If I do go to generic and sort by catalog descriptor, I can just go and type in H. Got to get rid of that one first. And then it's found a heater. So I can put that, okay to that. Or if I go catalog insert again, and I'll just get rid of the filters so you can see. Delete. There's all my generic devices. I could add extra, I don't know what. All right, so. But again, if I go to catalog descriptor and just change my filter to be L for LED, there's an LED. Now this circuit wouldn't work, but it's just the point, as I say, the fact that I can select from catalog more than one way to do things. And the other thing that is important, while American symbology is way different to the IEC symbology, you do tend to draw from left to right or top to bottom, but there are certain cases when you want to reverse things. And so let's go and find a normally open thermal switch, for example. Now, if I go and put that in there, okay to that. Now, as I say, if you wanted to reverse it, the normal thing you'd do is you'd find out what the symbol was called using attribute edit. There's its block name, VITSO2. I go into my Imperial schematics directory, find the symbol, mirror things and all that. Take a bit of time though. With our software, you can do this. If I go back to Elecdes, I go reverse symbol, it'll do it for you the first time and build it as well. So see that, it's flipped it around. All right, so there's that. And then the last couple of things I want to show. First of all, I'm going to go to catalogs again. To reinforce, I'll show you, open up the, remember I had this Schweitzer Engineering Laboratories. This is an SEL 451 that the customer wanted them to do it. What I'm going to do now is show you the Schweitzer as we originally did it in consultation with Schweitzer. So first of all, let's get rid of the thing there. And if I go to Schweitzer Engineering, now what I'm going to do here, insert column, I'm going to go for W, wiring diagram template, and I'll put catalog number as first. Okay. And if I have a look, I'll find my 311C is the big one. What you can see, the 311C. Okay, from here down to there is one relay. So it's got a whole lot of subcomponents, 40 subcomponents or something like that. Now what I can do here, again, I just zoom and line it up. But the important thing is I can just go next available because I've already got 4 relays. So it'll jump straight up to R5. Okay to that. Now the other thing I do in here is I put in some discrete wire numberings, but not on all of them. The key point, which I don't know if I actually mentioned before, is we keep it simple. And this is why we can produce wiring diagrams. We treat a line segment as a conductor, i.e. a wire or a cable, and a polyline, if you want to have an arrow saying service this in 2025, make it a polyline. And if you have conductors with no conductor names, it will let you know that at the end, which is one of the errors I showed, which is why I don't put in all my wire numbers. I just do a little crossing on some, and you can see it's assigned discrete wire numbers. Actually, exit, let's cancel that. I will go and draw, because what I didn't do is from there on, so I'll do it from there. And you can see the last wire I had on my drawing was wire 15 on that second motor. It's coming up with wire 16. And you can see it's put in wire 16, 17. And I've got wire 18 going to B17 and wire 19 coming out of B18. Escape. Now, two parts to this. First of all, I talked about multi-terminal devices right at the start. Remember, non-standard devices. This is how they were originally done for Schweitzer. Click on that. There's my advanced distance recloser, sub-assembly, auxiliary power supply, 232 ports. So as I say, inputs. So this is how we did it for them, and then they wanted it done completely differently. But that's the point. So those are multi-terminal devices. Now I've shown you those. I get rid of them because the next thing I'm going to do is go File, Save, and generate wiring diagrams. And now if I have a look, there's that relay that I just put the contact in for. Takes up a bit of space. So again, but if I cancel that, there's further proof. If I have a look in, there's my wire 18 and wire 19 going into B17 and coming out of B18. So there's proof that we can automatically produce wiring diagrams, and that's a bit of a wow moment for a lot of people as well. All right. Okay, now the last thing to show is PLC IO cards. The point I want to make here is another one of the tools outside in the CAD session is our PLC wizard, because PLC programmers can be notoriously slow in giving information. So if I go to PLC wizard, create a new PLC card configuration, again, I show them how it works in this case. Okay, so if I have a look, if I have a look at my 17460W16, the important things to note are the terminal configuration. I've got one power 8 digital outputs, one power 8 digital outputs, and the actual terminal numbers which correspond to the things above. Okay, so again, you want to group, if I look at a 32 output card, that one's got two power 60 outputs, two commons. I could group everything together. It's flexible in terms of how you stack things together, if you like. But I'll stick to this 17460W16 because it's not too big. Okay, edit the addresses and descriptions. Now, this is the sort of stuff that could be coming from a Excel spreadsheet. I just fill in some information, Control C and Control V, and right click, increment so it's something different. 1 to 16 there. Okay, to that. Okay, and then I go that wiring styles. Now this, the first two, I'm going to go select wiring style, and I'll make them one wire spares. This is where I point out it's got a hash sign, which looks a bit like Protogen. They're not, but they're little macros that we built. Now, in the old days, let's select wiring style. Here you can see AI, AO, DI, DO. DIO, like this one, that's it can be a digital input or a digital output, and it's got a limit switch. In the old days, even if it was only slightly different with a push button instead of a limit switch there, you'd have to have a macro built. Not anymore, because if I go okay to that, next. Now, Allen Bradley, unlike some manufacturers, they like putting address information on their wire name, so there's that. Individual terminals and cables if you want to. But this I show, all right, in this case, as I say, in this old days, that have always been limit switches, but I can now go into, for example, Allen Bradley, and go and find my limit switch. Cat's whiskers normally closed, and wobble stick normally open. Sounds a bit Mr. Beanish, but go okay to that. Thank you very much. Save, finish, and it's saved it. And so now I can go back to my CAD session, and I can point out, then I can go draw a configured card. And it will now go and have a look, which will be at the bottom because it's alphabetical. Oh, not quite, because I've got revisions. I forgot to turn revisions off. PLC card. Now, again, the point I want to make is, if I switch to horizontal, instead of saying top or left or right, it says top or bottom, but I'll stick to vertical. But the other point is, I showed you in the overview at the start, I can break things up. Normally this would be done on 3 separate drawings, but I'll finish this first bit up with stop out number emergency. Oh, hang on. Let's start at the right place, and then stop out 5. Okay, chuck that there. And then the next one is going to be out 6 down to there. And the next one, the final bit, which would be on the third drawing, is out 11 to the bottom. So again, it is quick, but of course I also reinforce, don't forget, in conjunction with you PLC for Progen, it can be even quicker. It's what's called a nested block, and they can certainly change the building blocks that it's built out of. Now I've shown the drawing side of things. I quickly go on to a little bit of report generation. Saved the changes on this. And for the generation here, all I'm going to concentrate is generating a report for IO cards. Turn these off as well. So it's better. Don't want back annotation, that's all. And compile reports. Now what it's going to find here is errors. And here you can see short circuits, open circuits, unlabeled wires. Those are the wires that are line segments that don't have any line numbers on them. Short circuits, if I have a look, here I've got two cable markers, C13, and nothing in between them. That's a short circuit. So reduction of errors is a useful thing to point out. I then show them the last report I show, as well as if I go and have a look in here and just my PLC index report, D4. And there's one of the reports. And I'm going to generate a lot of reports of the other drawings, but as I say, there's proof that we generate reports automatically. So thank you very much for the drawing side of things. Saved you changes. Finally, we're going to open up those three drawings that I showed at the start, which we never actually looked at in the CAD session. So zoom extents, reinforce the fact there's that lamp that I changed to being DS1002 red from being DS3 in green. This is drawn horizontally as opposed to vertically, which is what I've been doing. I've got R1 and R2, R30 and 31. The coils for R1 and R2 are on this drawing. The coils for R30 and 31 are on my second drawing. I also have a jumper, LK1, between two terminals, 10 and 14. And I've also got wire extension markers going onto my next drawing, because my coils, as I say, for R30 and 31 are on my second drawing. So we've never looked at this one, even using our batch printer. The next drawing, US demo 2, I could leave these open. But again, the point I want to make here is I've got R30 and 31. And if I go Elecdes cross-reference preferences, the fact of the matter is, I've already shown you, this is where you do things like grid spacing. I've got high primary. I don't want to see a picture of the coil underneath the coil, but minus 4.5, minus 1.5 is where the cross-referencing is going to line up nicely underneath R30 and 31. And the reason I show that, I mean, obviously that big Schweitzer relay I'd be doing on a separate sheet, and I'd turn hide primary off so I could see absolutely everything because it's on a new sheet. But the third drawing in this little project, two things to point out. Save the changes. First of all, if I open up the drawing, it is a vertical ladder. If I had my cross-referencing underneath the coil, it would be smack on top of the lamp. But we have been around for a while. So if I have a look here, there's a little button, insert cross-reference. We can overrule where it would put it, which is underneath the coil, and put it there. And I've also got, as I say, their line segments, conductors. So that safety changes there. Yep. And because, again, I'm reinforcing I can do a lot of things outside the CAD session. Let's go back to the right project, create project D1. And first of all, global edit. Now, first of all, let's go and change those generic red lamps, catalog select, into a real manufacturer. Rating 3107 is them. I think I've changed my relays. So same manufacturer, just reinforce the fact I'll just reselect those. Okay, and same manufacturer, catalog select, reselect that. Thank you very much. Yep, load it back onto the drawing. And then I'll go back, annotate cross references and all that, and compile reports. Now, again, this is where it will tell me if it finds any errors. And it should find at least one. First of all, it's found exactly what I want, unlabeled wires. That's that third drawing, because as I say, we've got this auto insert function. As long as you're going from top to bottom or left to right, I can go and see what my last wire number was, which was wire 44. In New Zealand, a well plus one is wire 45. And I'll use my good old 1102 wires. Okay to that, and then compile reports again. So it's, you can quickly fix things. And not only that, now what I did on this one, it should have only one error left, and that's a catalog error. What I did is I manually changed information on the drawing so it doesn't match the catalog. I can navigate to warning. It's opening up my bill of materials, and it's saying that one's got their thing. I just still don't know what's going on with it, so I can go navigate to component. If I didn't have my CAD session open, let's go back. If I didn't have my CAD session open, and you see it's opened it up and then it zooms straight in on it, CB2. So it's pretty easy to track down. Here again, I show them there, it's put my cross-reference information, where the cross-reference information is found, US demo G10, US demo G9, US the second drawing C9. And if I have a look, there's the actual cross-reference information. While I'm here, just remember C1 goes into my motor. I'll come back to that. And if I have a look here, we've also got the navigate function, just like everything else inside the CAD session. If I click on cancel, sorry, navigate on that is what I was trying to do. There's my third drawing, which didn't have any wire numbers, and you can see straight away it's got wire numbers. I would also point out that the navigate function is pretty useful on a project. You've got 500 drawings and they want you to change PB5. Just right click on the navigate button, type in PB5, and you can see it's found it on my second drawing. And you can also see it's telling me where the extension of the wire goes. So that is quite useful as well. I'll then have a look at a couple of other reports. For example, again, I could look at it in the MDV file, but I'm running out of time today here, so I'll just do it in here. Bomb sum. There's the, sorry, D1B sum. Okay, there's the lamps that I changed to Merlinger and from generic, could change it to something else. If I look at my ferrule report, this D1 ferrules. Okay, this, for example, it starts off with my jumper between the two terminals, then it goes through all my wires to my cables at the end, to my motors. And so quite powerful. You can just export to text and feed it into your labeling machine. Okay, let's close these down as well. All right, now the other thing I'll just finish off here is I'll put in a big size, an E-size sheet, which I'm now going to delete as soon as I put it in, just for economies of scale. Arrays, wiring diagram and terminal strip generation. I've already showed you it can generate things for things like Schweitzer relays, but first of all, let's have a look at my terminal strip. Remember, my terminal strip was TB10 that I changed at the start. Okay, edit terminal strips. And this is, again, a bit of a wow thing. We've had people that had too big a terminal strips for the sheet. I can just go split. There's part 1, and there's part 2. I can join them back together. I can move terminal 6 to the top. I can move it down. I can move it up again. I can flip it from being left to right. So just like everything else, we're flexible in terms of how it's displayed. And if I look preferences, terminal strips, cables, leaders, whole lot of flexibility in there. The easiest way is to show. Now, I point out, I already generated a pictorial representative wiring diagram from that Schweitzer relay, but there are no standards for wiring diagrams. So as a default, we will just build a box or a circle, and you can see now that's exactly what it's done. But that's pretty powerful in itself. And then the only other thing that I've got is you can see it's joining cables when it can as well. Okay. Now the other thing I've got is if I open up my US demo drawing, as I say, there's that, because I always forget it's relatively recent, but it's actually quite a useful thing to finish off with. Core sheets. A cable 1, because if I look, cable 1 was going into my motor 1, and there it is. And so it shows you that it goes TB10, so quite useful stuff. And thereby it finishes a standard drawing, and I'd wait for a few questions. But hopefully, stop sharing. Hopefully that's given you some